In this video, we will review chain rule to do differentiation. We will also be looking at when there is a need to use chain rule and when we do not need to use chain rule. So before we look at this question, let's recap the use of chain rule. Chain rule is used to differentiate expressions like this. When we have a function raised to a power n. So how do we apply this rule? We bring the power down and the power decreases by 1. When we do this, fx still remains inside this bracket. Next, we need to multiply by the derivative of fx. So what we do is to differentiate this function and multiply by this derivative. So this is how we apply chain rule. So let us look at this question. How can we differentiate e power 2x plus 3 to the power of 5? So you can see that this looks like fx raised to a power. Therefore, we can use chain rule to do this differentiation. So, in order to differentiate this, I will be bringing the power down and the power will decrease by 1. Whatever is in the bracket will remain exactly the same, so you will have e to the power of 2x plus 3. Then we will multiply this by differentiating whatever we have in the bracket. Now what we have in this bracket is e power 2x plus 3. How do we differentiate e power 2x plus 3? We will get e power 2x plus 3 times 2. This 2 is what we get when we differentiate the power. So this is how we differentiate exponential function. So this question requires both chain rule as well as differentiation of exponential function. Now we can simplify this answer. 5 times 2 is 10. E power 2x plus 3, the whole thing is raised to a power 4. So I can actually simplify my answer by multiplying the powers. Then I have another e power 2x plus 3. Now since both of these terms have base e, I can further continue to combine these two together by adding the powers. So my final answer would be e power 10x plus 15, the whole thing multiplied by 10. So we see that this question can be done using chain rule. However, let's look at another method which can be used to differentiate the same equation. Now the equation is e power 2x plus 3 raised to power 5. Using indices rule, we can also express this as e power 10x plus 15 by multiplying the powers together. Now when I write the expression this way, you notice that it doesn't look like fx to the power of n anymore. So there is no need for us to use chain rule to differentiate this. To differentiate this, I can just use the derivative of exponential functions. So differentiating e power 10x plus 15, I will still have e power 10x plus 15, but I need to multiply by the derivative of the power. So I multiply 10. You can see that both our answers are the same, and it was much easier to use method 2 as compared to method 1. So at this point, do think about when you would need to use chain rule and when you might be able to simplify the equation first and then avoid the need for chain rule. Let us look at the next question. Now we're going to differentiate ln 3x plus 5 power 7. Now do note this power 7 is only applicable for the 3x plus 5. So technically we do not see the function, a whole function raised to power n. So we do not see this whole function raised to a power. So what we can do now is we can start differentiating this. How do we differentiate a ln function? Whatever we see inside the bracket will become our denominator. Okay, why? Because differentiation of ln function will basically be fx in the denominator and f prime x in the numerator. So what I've done is just to copy down this function as my denominator. What goes in the numerator will now be the derivative of fx. So now I need to differentiate 3x plus 5 power 7. Now to differentiate 3x plus 5 power 7, this is where I need to use chain rule. So I will be bringing the power down, and then the power decreases by 1. Next, I multiply by the derivative of whatever is inside the bracket. So 3x plus 5, when you differentiate, you will get 3. Now this can be simplified because there are common factors in the numerator and denominator. So I'll be able to simplify this to 21 over 3x plus 5. So in method 1, we started by differentiating the ln, and then within the differentiation, we had to apply chain rule. Now let us look at method 2. Method 2 again involves how we can simplify this equation before starting the differentiation. Now the first method was a bit complicated because of this power 7, which we can avoid by bringing the power down using our logarithm power rule. So what happens now that I've brought the power down? If I now differentiate this function, this 7 is a coefficient, so I will just be multiplying the 7 to the derivative of ln 3x plus 5. How do we differentiate ln 3x plus 5? 3x plus 5 is in the denominator. The derivative of that is 3, so that goes to the numerator. So my answer will be 27 over 3x plus 5. Again, you can see we get the exact same answer as method 1. However, for method 2, we didn't need to use chain rule because we brought the power down using the logarithm rules. So in short, when are the times we do not need to use chain rule? Now, if there's any way that we can simplify the equation first to avoid chain rule, then we will do that. If there are certain scenarios where it's not possible to simplify, if it is definitely fx to the power of n, then we will need to use chain rule. So some examples where we do not need to use chain rule: when we have e to the power of something and the whole thing is raised to power 5, for example. Now the strategy would be to simplify using indices rules. So we can multiply the powers together, so we will not end up with fx to the power of n. Similarly, when we have ln 2x plus 1, the 2x plus 1 is raised to power 7. We can again simplify using the logarithm rules by bringing the power down. Other scenarios where you do not need to use chain rule would be simple expansions like 3x plus 1 power 2. It might be easier to just do the expansion using the identity. Of course, in this scenario, you can also choose to use chain rule. However, there are some scenarios where you have no choice but to use chain rule. So those are when, for example, the power is a -1. There won't be any way for us to expand this. When the power is half, so for example, square root 3x minus 1. Or when the power is bigger, so therefore it will not make sense to do the expansion, we can immediately use chain rule.